Okay, ready to talk about data engineering from a fresh perspective? Our next speaker is Nikhil Suresh. He is the director at Hermit Tech, and Nikhil's blog, Ludicity, recently got a lot of people talking about the ethics and over-adoption of AI. So you know he's going to challenge our thinking. He brings a mix of psychology and data science to the table, and he's here to empower our software teams. Today, he'll show us exactly how to transform strong software engineering skills into an effective data engineering stack, giving you the mastery needed for deep historical and cross-system data analysis. Welcome, Nikhil.
Okay, cool, this is on. Good afternoon. Thank you everyone for coming over. As you've seen, I'm Nick Suresh, and this is our definitive guide to data engineering. So normally I work as a data engineer. I'm also the director at my own consultancy, Hermit Tech, here in Melbourne. And I know the talk has just started, but I realized about 3 days ago I made a mistake, which it was too late to fix, which is I didn't advertise anywhere that I write a well-known blog under the name Ludic, and I didn't put AI in my talk title. There's no AI in it, but it's not my talk title. So I assumed I was just, no one would be here. So thank you for coming by. And in exchange, I want to give you a definitive guide to data engineering. So I want to motivate this for a second, like why we'd run a introductory talk. And the main thing I've realized running our consultancy is that a huge number of very, very strong software engineers don't really know what data engineering is. So something we've run into over and over is we will turn up at businesses and they'll be doing work more complicated than like what I could reasonably accomplish on my own. And at some point, management goes, we need to do more with our data. Sometimes there is buzzwording. The most common one is we need to turn our data from a liability into an asset, phrases like that. And then I look at their stack and things aren't quite right. Like a lot of things have been implemented that don't meet the definition of what that should be. And that's not the engineer's problem. They're just in a hurry. It's not their main job. The real issue is we explain things very, very badly in data engineering as a field. So this is from the data build tool, DBT. It's one of the most popular things in data engineering. It's basically beloved. Every data engineer likes it. We don't have many issues with it. But this is one of the first things on their website before they've even really described the product. Like this is the first thing they want you to know about DBT. Over here we see analytics and AI. DBT doesn't actually do that, but it's on the chart, which is very important. Over here we have data sources and data platform. Both with raw data, analysis, ready data, they're both there. Which part of this is DBT handling? That's not explained here. And my favorite thing about it is just this key up here. I work with this all the time. I deploy this at all sorts of companies. I don't know what that's supposed to be, and no one on my team does. But it's very important. This is the first thing you see on the DBT website. Or this is from a very well-respected person in the field, so I mean this respectfully, but it is the most confusing tweet I've ever seen. There are no warehouses in a mesh. There are autonomous data product quantums, so on and so forth, transforming and serving immutable bitemporal data. Everyone on my team thinks we know what this means, but we all disagree. So the net result of this is, we mostly consult. And when you're consulting, you have to be very, very calm. Imagine turning up to your lawyer and you say, I've got a problem, I'm getting sued, something's going on. And even if you've really badly messed up, imagine if you freaked out and he just went, oh, you're screwed. You should have done that. Even if that's true, that's not what you want in a lawyer. So when we consult, we turn up and we're just like, well, this is okay, but none of my clients are in the room here and they don't watch engineering talks. It's not fine, all right? Like the industry is not okay on data engineering. So what I want to walk us through today is assuming there's no data engineers here. If you already know data engineering, you shouldn't be an introductory talk. I want to run you through what the weaknesses in a conventional application database would be, which is stuff you use day to day. Walk through what it can't solve, a very high level definition of what the parts in a data stack are. And then I'm going to just walk through foot guns, like products that look like they will solve your problems. And I'm not going to get into exactly why all of them don't work. I'm just going to tell you which ones I get paid to fix the most. And then you'll never have to pay me. So let's get into why you shouldn't use an existing database for all your analytics. So to walk through this, let's imagine we're running a company together and we're selling fruits. This is beautiful FruitDB. It's our application database. What it is doesn't matter. It could be Postgres or SQL Server, anything you want. Let's assume it's relational. So these are, I mean, most people here would work with a relational database, unless you're in MongoDB, in which case I commiserate, I'm sorry. But these are good for storing application state. And they're very fast at specific operations, right? They insert single rows really, really quickly. You can serve a bajillion million, not literally that many people simultaneously with one of these. But the main thing, like as a data nerd, we value in this is the data model you get in a well-designed relational system. You put things into third normal form, and it stops your system from getting into inconsistent states. This is not a talk about third normal form, but I will do a super quick summary because not everyone's education covers it like very formally. But to think about what is not third normal form, imagine a business just running everything out of a spreadsheet. We've made 3 fruit sales to John and 2 to Sally over there. And it's just a spreadsheet. Let's say John calls you and he says, I've legally changed my name to Jacob. So you pop your spreadsheet open and you go, I don't want to upset John. We're going to get his name right. But then you get a phone call after changing one record. So you just walk away and your database is now in this strange state where it looks like you have 3 customers. 2 of them, John and Jacob, share an email, which doesn't even mean it's wrong, right? They might work at a company and be sharing an email address. They could live together and have a shared inbox. I don't know if people do that. It's entirely possible. But this is not a state you want your database in. Now, a relational database that's well designed would have separated these, right? So you'd have a customer table and you'd have 1 record per customer and you'd have 1 record per item. And it becomes impossible to change a bit of data in one spot and then get into a weird state where it looks like you have 5 customers. So that's all really good, but there are a couple things an application database doesn't do very well. The first one is you can't run queries that touch data in multiple databases very easily. That makes sense because you're writing SQL. How can your SQL hit things that literally aren't in that system? That's a pain. 2, what if the business needs history that doesn't exist in your application state? You have ways of tracking state in your application, right? Like you can soft delete every record that ever hits the system, but you have to engineer around it. And the business will tend to care about state that the application might not. And the business might also very abruptly ask for some state that you didn't think of. Like that's entirely possible. They'll go, you know, a good example is like on our company website, you know, someone pops a email in somewhere and they change it later. I don't track every historic email they've had. Maybe I should. I just, you know, never got around to it. If you touch enough rows in a database, you can have read replicas and things like that. But relational databases aren't very well optimized for huge queries. So you might be able to read 1 record quickly and run a bunch of joins. But if you try to sum across every sale the business has ever done and you touch 100 million rows, you can cause serious outages. Or even if it's a replica somewhere, you can lock other analysts out for quite a while. We had a thing this morning where someone ran a query that ran for 24 hours and just shut the company down for a little bit in terms of analytics. And finally, and this is a big one, as a developer, you know about the application schema. Most of your analysts will not, because your database was designed for transactional integrity. Many analysts are pretty new to SQL. They're not going to go into your application code. And the task of figuring out what sequence of joins produces something that is correct in terms of business logic, like the definition of a sale, that's actually pretty hard in many cases. So those are the problems we're going to tackle, and we're going to build a stack together that starts to solve those. But suffice it to say, we can define data engineering then as the simple practice and storing of practice of storing all the data in a business in a way that maximizes the business's ability to answer questions. If you could do that from an application database, which some businesses can, you just wouldn't need data engineering, and that's absolutely the case for small businesses. But let's start walking through it. So the first thing is every business does have multiple data sources. Even if you have one application database, you'll probably have counting software, GitHub logs. There's always something that doesn't live in the thing you are used to dealing with. That is basically always the case. And we need to figure out, let's like solve the first problem. How do we answer a query that needs to hit multiple systems? The traditional way, if you don't have any data engineering capability, is the most common one is Excel. Like you just port everything into Excel. I spent the first 2 years of my career as a data scientist just getting asked to deliver people things in Excel. It was very disappointing. Or if you have more expertise on hand, you can get someone to do stuff in Python. You can load pandas data frames up, and I actually don't know if everyone knows what pandas is in the Android world, but I'll assume you do. You get Python, you do some magic, you do the thing. But this causes problems, right? Firstly, you can put Python files or whatever analytics code you want in network drives all over the place, nothing centralized, you can't replicate things. People might not use version control. There's the classic Excel spread of just, I did this at university. I stopped when I graduated. Not everyone stops, and that's a problem. So we're trying to avoid this. So what is the alternative? We have a bunch of databases. The solution is kind of dumb. You can just put it all in a bigger database, right? Like that's, let's talk about that. Is that a really dumb solution? Like, sort of, you're just copying a bunch of stuff over. But it does solve that problem. Everything is in a database right now. So when you hear people talking about data warehouses, it's really just an even bigger database. And I think something that's important is a data warehouse is conceptually distinct from an application database. That is to say, it's a database for a different purpose. It doesn't have to be physically distinct. So those could be 3 Postgres databases. And for a small business, that could also just be a Postgres database. And you just call it the warehouse, but it doesn't have to be a database specialized for analytics, although you usually pick one that's specialized for analytics. So we've got our super simple solution here. We have one big data warehouse. So the first thing data engineers do, they fill warehouses up. Now, what about this question of state, right? So we could try and soft delete everything ever and figure out how to make things efficient and index things the right way. But there is another way, which is a little bit simpler. And I think importantly, you're not in control of how every upstream system manages that. You can control how your application tracks deletes. You cannot always manage what a third-party vendor is doing. So what, and I'll put this out to the room, classic programming problem, we have weird things with tracking state. What could we put in there to solve this issue? I'll wait a couple of seconds. Does anyone know what would go in before a data warehouse to solve a problem of state? Triggers is not a bad one, but there's actually only one way to stop the state from causing issues, and that's Bitcoin. It's the only way to keep the state out of your business. No, it is something called a data lake. Now, this is something that is so conceptually complicated that I've had a lot of meetings. I've had 3 in the past month. I've gone into a meeting and someone has shown me an architecture diagram, and it's been an engineer. And it's been an engineer who's doing something really, really complicated in their day job. And they've shown me a big data lake in their diagram. And they go, can your team help me make one of these? And I've learned to always ask, do you know what that is? And almost every time they go, sort of. I was told I need one and it needed to be before the warehouse. So it's very complicated, but I'll ask you all to stick with me. It's cloud storage. There's actually nothing else. It could be a network drive. That is all that goes in there. So we have this intermediate step where every day from your source systems, and there's lots of ways you can do this. Like you can stream stuff into a data warehouse if you want to do something super fancy. But the most boring, basic way, if you're a normal engineer who's been asked to data engineer, to not footgun yourself is to just take a copy of each table and land it in a format that looks basically like this. Environment, database name, table name, and then just in this format, the date you got it, and you put it in a big file somewhere. That's basically all the data lake is. And now you've, as simple as that is, we actually get a lot of benefits. One is we have snapshots of the data coming out of every system. even if you overwrite the data warehouse every day, right? So you're just deleting it and putting the latest copy in. If tomorrow the CEO comes in and he goes, I need to see every email change ever, you will get most of them by going back and reprocessing the file. So we've solved some of the problem. If a column changes unexpectedly and can't load into the warehouse, you at least didn't lose the data. It's just sitting in cloud storage, and you just need to edit the warehouse schema so the new table fits in. And most importantly, you don't actually usually do this at the warehouse level, but you can just store non-traditional data types. So like if you have call data coming from a call center, you're probably not analyzing that in SQL, but someone will want to run machine learning on it. If it isn't a data lake, they can at least get it out in some structured format. So we really just have application databases, cloud storage, bigger database. It doesn't even have to be bigger. It can be about the same size. It's the sum of those three. And that knocks out the second issue, right? And we're already looking at most of a traditional company stack. It's just cloud storage and then a bigger database. And we're going to get to these last two in one step at the same time. So we have queries that are too slow and analysts needing to know about transacting against a complicated schema. So I'm going to introduce you to the main phrase or the main acronym we have in data engineering. Some of you might have heard of ETL or ELT. Is that, I see some level of nodding. Okay, so it's pretty straightforward. The E is extract. That's all you're doing when you copy stuff over. So there's no rule about how you do this. Some companies use pretty sophisticated tooling and buy products like Fivetran that cost $1 bajillion and automate it for you. Other companies use open source stuff and write your own code. Someone told me, and I'm not 100% sure if this is true, but I trust them. They said Canva just uses cron jobs, and it's sort of fine. Don't have to worry about it too much, but you're just copying stuff into cloud storage. You have L, load, that is putting it into the warehouse, so you can actually hit it by SQL query. And finally, you have the last step, transform, which is maybe the most conceptually difficult one for a normal engineer, because these are things you probably do every day. My friend Efron always says most of engineering is just reading bytes and then writing bytes, and that's a little bit reductive, but basically true. Transforming is, you're still reading and writing bytes, but you have to write a bunch of complicated SQL to do it. So this would be what your application database might look like. So if you want to get some information out, you have to run a series of joins. If you're an analyst, you have to like left join on order ID and then to product ID, and then you could get everything that John ordered. That's fine, but it does require that the analyst downstream knows exactly what they need to join up in your database. And I'm guessing this database is much simpler than anything any of you work on day to day, right? It's not going to be 3 super neat tables where it's a no-brainer. It could be really complicated. There could be weird issues with nulls. Like you can just get weird cardinality issues and get a million records out you didn't expect to. So when, if you've ever been buzzworded with stakeholder empathy, like this is what people mean, which is just, it's hard for people to work with your schema. So the transform step is it's actually called dimensional modeling. So we have relational models. That's the stuff that stops duplications. Dimensional modeling turns everything into facts and dimensions. And I will explain what facts and dimensions are. This is what a really bad fact table looks like. It is pre-joined. I don't like the word fact, but a way to think of it is it looks a lot more like an event log. Like we have a time, a couple of really bits of basic information, and then some numerical values you might be interested in. The main thing I want to point out is someone wanted to do something super basic, check sales tomorrow. There's no join here anymore. You just sum quantity, and if you needed to, you could put in a where clause for the day. And that's always correct, and you basically don't need to know much about the business. Like that's very self-explanatory. But this is a bad fact table. However, it does solve some problems straight away. Even though it's bad, everything is materialized. The joins are already done, which is what is expensive in a database. So it's very fast. And even though I said that a warehouse doesn't have to be physically distinct from a normal database, you usually will pick a database that's really specialized at just summing a bunch of rows. We have specific ones for that. So it's going to be very, very fast. And now let's add what we call the dimensions. So we have the facts. This is starting to look like more what a fact and dimension model is. So we'll see, the weirdest thing about it is we just have this, I think I'm the first speaker to walk away from the podium. This is very scary. So we have this date dimension over here. And what you're doing is you're enriching the fact table with things that people can use. So for example here, normally if you want to find out every sale on a Monday, it's the worst because you have to figure out how to calculate all the Mondays in a specific range and or even like leap years. If you want sales on leap years for some reason, right? You just have to figure out how to do it in SQL or whatever. But what you can do with a dimension is you can populate a gigantic table. So for example, you might just put in 30 years of information on every date that passes in those 30 years. And then you can load them up with information. You can flag them as public holidays. You can say what the holiday was. You can say what the day was. You can get the month in like every conceivable month format. It could be January, Jan all caps, whatever works. And now when you're running your queries, you join against a pretty self-explanatory dimension, and you can very easily filter for a specific day. So a date dimension is the most common thing. But usually what you're going to do is just keep slapping on as many as you can on there. Like whatever the business can think of, you put one in there. And it's usually typical to think of like the fact table as the important thing. But having a ton of high quality dimensions is usually what determines the quality of a data warehouse. So for example, in this case, it would be very, very easy for someone to sum every sale on a Monday that happens to be a public holiday in a fair trade region. And you could have an extra thing here in Southeast Asia instead of Malaysia, right? Like any way you can categorize data, it makes it very easy to slice and dice. And that is enough to give your analysts a way to very quickly and somewhat, application agnostically begin to run analytics. You have a single source of truth, you have the defined fact table, everyone is working off the same. You're never going to have an issue where two people calculated Monday slightly differently, right? We're all in agreement, you can reuse that everywhere. Normally, and we'll get into a little bit of this later, you can also extend this by using tooling to perform governance and documentation around the dimensions and facts. But the end result you're looking for is essentially a bunch of tables where everyone in the business has like a complete catalog of what facts are available, what dimensions are available, and everyone can just sort of agree on what's going on. Businesses vary massively in their ability to get this correct. Some businesses nail it from day one and they always know, well, not always, but to a high degree of certainty, they kind of know what's going on. Most businesses totally whiff this. If they did not whiff this constantly, there might even be a few people who are like, I didn't know people got this wrong. They get it so wrong. So to recap, you have an application database, you're pulling stuff into cloud storage and you're saving a snapshot of every single table every day. You load it into a bigger database, and then you just do a little bit of SQL at the end, or a lot of SQL, to get it into this specific format, which is very easy to transact against. That is roughly enough for everyone here to like not set the company on fire. Like you might not nail it, but like, for example, I know of a major, what can I say with NDA? I can't even tell you what industry they're in. I can tell you they make a ton of money and they hired an engineering team with a value of over $2 million, but they weren't data engineers. And when they built their data lake, instead of saving snapshots of every table, they just overwrote the history. So they don't actually know what's gone on historically in a bunch of tables for no reason. Storage is very, very cheap. They just needed to Google a thing, but it didn't occur to them there was like another way to do it. So you know enough not to make super obvious mistakes, but I do want to run through a couple of tooling things because there are some tools, and this is not super comprehensive, it's a little bit opinionated. I will give you some ideas on tooling that will stop you from getting into like trouble. So I'm going to rule out a bunch of things, but like for instance, at the extract and load phase, where you take things from the application database into cloud storage, the warehouse, these are like the 4 tools that don't panic me when a client says they're using them. right? Like it's probably okay. Airflow, Prefect, and Dagster, they all do basically the same thing. They take your code and they run it on a schedule, and that's why, presumably, if Canva is really just on cron, it's because that's what cron does. Interestingly, Airflow, my partner's in the audience, and Airflow is the product that Astronomer runs, who's, they had the whole drama with the CEO. And it's the only time in years that she's been interested in anything I do. And Airbyte in the top right, it's basically the same as the others, but it has a ClickOps interface. We don't like it because if you're engineers, you're not scared of writing code and you actually think writing code is efficient, but it's okay, it's fine. What I'm trying to get at here is anyone ever pitches you on something that's not on this list, I actually think you should be kind of alarmed. Like these just solve the problem and they're mainstream. In terms of your warehouse, I did mention you can use Postgres or SQL Server, whatever you want. These are the two products that don't panic me as well. If a client is on Snowflake, I go, that's probably fine. We don't have any clients on BigQuery, but it's very well regarded. And it's also a Google conference, and I haven't said anything about Google. So I feel like this is a nice concession. Great job, Google. People like BigQuery. But for example, Amazon has Redshift. Everyone hates Redshift because I think it's just a fork of Postgres and it makes everyone sad. You can use it, but like if you're greenfields, just don't. There's no reason to. And this is the big one that people don't really know about. And I would say it's the biggest mistake clients make when they get everything else right. They just don't know DBT exists. Partially that's because DBT also stands for dialectical behavioral therapy. So it's hard to Google it. Bad choice on their part. It's actually the data build tool. And what it does when you're not looking at their horrible marketing material is it extends your SQL syntax a little bit. So it extends it with Python, which I saw some head shaking earlier when I talked about pandas. I realized Python is not as well known in this space as I thought. But basically, instead of just writing select from a table, you can put the little squiggly braces in and then it runs Python for you. And as a side effect of that, it returns the name of the table. It does things like it starts logging everywhere you've called a specific table from. So it builds a big lineage graph. And you can do all sorts of weird stuff. Like I can't imagine why you'd want to do this, but you could have it fire off a post request every time someone runs this, right? Because it's just Python. And it also comes with a bunch of functionality to document the columns in YAML. I don't like YAML engineering, but I do it in DBT. So you can have this thing where you can say where the data comes from, what it's about, what the columns mean, and then people can stop bothering you when they need questions answered. They just go to this thing if you keep it in good order. I do need to talk about these two products. People on these make our consultancy a lot of money. I feel like it's okay to be mean to Azure Data Factory because it's a Google event. It's very, very bad. But there's a very high, they make a lot of sales. It's very popular because if you're on Azure, it is like the Microsoft recommended way to do it. I won't get into it now, but like very, very high fail rate. Databricks is Snowflake's main competitor. This is a very controversial opinion. Databricks is not like a project killing thing. It's fine. It's just that because it's just a little bit worse than everything else. Not everything else, it's worse than Snowflake and they cost the same amount. So you get the better one. Whenever a team buys Databricks, it usually means a decision maker has been compromised by a sales team. So if you see someone go like, hey, Databricks, a good engineering team can make Databricks work, but you need to like get someone away from your CEO at that point. Like someone's talking to him and you need to gently separate them, has been our experience. So that's most of it. I just wanted to leave with some like high tier resources. I'm very upset about this one. So going from left to right, assuming you've never had a formal database education, my co-founder Ash said that the best relational database book is unfortunately the Manga Guide to Databases. And I argued about this, but they convinced me it was the best book. I put these two up, which are respectable books, not about anime. So once you have your basics down, the Fundamental Data Engineering is the book I would give a software engineer who is tasked, someone turns up and says, we need a data platform, we're a startup, we don't have money to get like a super specialist in. you can run through that book in like 2-3 days. It's very, very good. And then finally, so that'll cover you in like the E and L phases, like how to pull stuff over and what you're doing. It even handles like stakeholder management and how to pitch the project to the business. This book is super big and boring. I think it's like 500 or 600 pages long, but it tells you everything you need to know about that dimensional modeling step. And you can probably just read the first 4 chapters, which will take you 4 days. You'll be fine. And has a bunch of other chapters which are very industry specific. So if you work in insurance, it has a chapter on exactly what you might encounter there. But super, super good book. And I just wanted to finish by thanking my co-founder, Ash Lally. So I manage the company and I program okay, but like I definitely have some sort of exec brain, like I get worse every year. Ash is our best engineer. This is them with their hat. This is their real LinkedIn profile. Which is hard to explain. And yeah, that's so yes, let's say questions. Do we have time for questions? Or are we? Okay, cool.
Thanks. That was a really good talk. I like how you use the term high tier when you were talking about the books. So I just wanted, I understand the purpose of creating that date helper table, but I just wondering why is that called a dimension?
So it's a little bit interesting, but kind of historically the way this was imagined. Well, you know, we talk about space and time as dimensions. So the idea was that you can look at a slice of time. So you have all your data and you slice out January to March 2025. And then we realized you can conceptualize everything as dimensions, right? You could slice out the dates, or you could slice out all products that are technically subtypes of a specific apple. So that's why they're dimensions, because literally you can slice as if they were dimensions. They use all sorts of analogies like cubes, and each face of the cube is a dimension, and then you pick the parts you want, you pull the data out. But that's like a really abstract and nerdy way to describe it to a normal audience. Even fact table, right? Really, when you say event log, everyone goes, yeah, those are events. When you say facts, people are like, all sorts of things are facts, right? Like what particular, why is this more facty than my application table, which is also full of facts? But yeah, that's the reason they're dimensions.
So is just so I understand correctly, so the fact and dimension are kind of opposites in that idea, or they're not, they're mutually exclusive?
Like, yeah, so you can find weird edge cases like in anything where something like feels like it could be a fact or a dimension, but most of the time, like something is clearly a fact or a dimension. But yeah, and essentially the way to know if it's a dimension is if it feels categorical and easy to filter on. And if something can easily be represented as a series of events, the way I like to think about it is if I can think about logging it in my application instead of just storing it, yeah, I'm like, that's probably a fact. Does that make sense?
Yeah, I think I get it.
Yeah, it is a little bit weird, but it's important that everyone also adjusts like the terms to Google, because a very common outcome as well is companies just paste the application tables into the warehouse and they tell the analysts to work. Not because they're lazy, it didn't occur to them there was like a thing that should be done at that point. Yeah, cool.
Hi, and thanks for the talk. I mean, it was very informative. So how do you slice, ETL and maintain security and permissions generally? What are the common themes there?
Yeah, okay. So it's, I'll talk about the warehouse level specifically. Like, let me just go way back here for a second. I'm not going to get massively into the extract and load steps because at the extract level, you can probably apply any security you would normally do if someone was exfiltrating a bunch of data. I don't know if exfiltrating is the right word. It's very malicious sounding. Taking data out. Once it's transformed, it gets a little bit trickier. Mostly you do it by just table grants, right? You go, this analyst can look at this table. You might put stuff in a specific schema. Where companies get into trouble is management teams get very overexcited sometimes, and they come up with these really elaborate models. So they go, we have the concept of, I worked at a university once, and we have the concept of a student and a this and a that. And they said each student can have data in one of 8 domains, and each bit of data in those domains can be private or not private. And there's also 3 levels of privacy. And that all sounds well and good, because you can go, well, now you have really fine-grained slicing and you can't look at data you're meant to look at. And they went to the developers and they went, cool, like, can you write a script that handles those grants and stays synced up with Active Directory? And it was just the biggest spaghetti ball ever. So my general advice would be, put stuff vaguely in schemas. If you can afford to, just let every analyst look at everything. If you have something super sensitive, instead of building a complex system, I would just pick a specific team, and they'd be the only people with read access on that table. And I would try not to get into very, very complex governance models. I have never convinced someone not to do that. They always do, and what always happens is they build the whole thing and they go, it's perfect, and then 1 week later, I did this to a client recently. I turned up and I needed just 1 row of data. It had first name and last name for a very sensitive project. And I had to go in and go, hey, you've put me in as this type of analyst. And I'm not actually the other type of analyst, but you're going to have to put me into the system as one so I can get that data out. And they just always end up doing it. And within 1 year, you have this beautiful model of who looks at what. And everyone is just logged into the system as every possible job description. Right, they'll just make you an executive because you need it for an executive report, and now you're just in there. So I wouldn't commit to any model where you're not 100% willing to tell someone, you don't have that job, you can't look at it, sorry. Does that kind of answer the question?
Yeah, but I meant more towards a multi-tenant system. Let's say if you have something like that.
Yeah, okay, multi-tenant systems are complicated. I won't get massively into it, but for a lot of our clients who want to build a platform and invite clients on, we tell them to build an API in front of the warehouse. The moment you don't want to have like a typo in some CI/CD that just immediately breaches a bunch of stuff, right? Like that's not fun. I would just don't have a multi-tenant database.